Imagine a force so powerful, it dictates the rhythm of a billion lives. It's not a government, it's not a corporation, and it's not some new tech. It's an atmospheric engine.
A massive one.
It determines whether the stock market rallies or crashes, whether a family in a remote village feasts or fasts, and whether the rivers flow or run dry.
You're talking, of course, about the Indian Monsoon.
Exactly. It's the heartbeat of the Indian economy, a huge cultural unifier, and, well, frankly, one of the most complex weather systems on the entire planet.
Oh, absolutely. It really is. I mean, it's a phenomenon that sailors have navigated by for centuries, and yet our modern supercomputers still, struggle to predict its every single move. It is the defining feature of the Indian subcontinent's existence.
Welcome back to The Deep Dive. This is a very special edition of our show, one that we've custom-tailored specifically for the Simplified UPSC by PPP community. We are incredibly excited to be walking you through this material today.
Absolutely. We know how crucial this topic is for your preparation, so we are really going to go deep on this one.
And before we jump into the eye of the storm, I just have a small, very humble request. If you're listening to this on YouTube, please just take a second to hit that subscribe button.
It helps a lot.
It really does. It helps boost retention and just make sure this content gets to the people who really need it. And if you are capable and you find value in what we do, supporting the channel on Patreon is, well, it's vital to keep this super useful content coming. We really couldn't do it without you.
And on that note, a massive shout out to all of our current supporters. You are, to use a fitting metaphor, the wind beneath our wings. You really do make this possible.
And please don't forget to like the video and share your valuable comments down below. We actually read them all and love hearing your takeaways.
We do.
Now, resources. I know you're going to ask. The free notes, along with practice previous year questions or PYQs, are available right now on the public Telegram channel.
For the really serious learners out there, the ones who want the full arsenal, you can get access to all the videos in this series at once.
All at once.
Yep, plus organized premium notes. And we're talking detailed notes, extra PYQs, and even model mains answers. To get all of that, you need to join the private Telegram library.
And it's simple to do. Just send a DM on the public Telegram channel to join that private library.
That's it.
Okay, housekeeping done. Let's talk mission. Today, we are doing a comprehensive breakdown of NCERT Class 9 Geography, Chapter 4, Climate. But, and this is a big but, we are not just reading the chapter.
Oh, no. No, reading is for bedtime. We are doing a strategic analysis. We're going to link the text directly to UPSC previous year questions from 2013 all the way to 2025.
So the idea is to show you exactly what the text says and then immediately show you how the exam tests that specific concept.
Exactly. Theory and application, side by side.
So grab your atlas or just close your eyes and visualize the map. Let's dive in.
Let's do it.
We have to start with the absolute basics. Section 1, climate versus weather. I feel like in just, casual conversation, we use these interchangeably, like, how's the climate outside today?
We do, and geographically speaking, that's practically a sin. We have to draw a really hard line there.
Okay, so let's draw it. What's the difference?
Weather is the state of the atmosphere at a specific point in time. It's what's happening right now. Is it raining? Is it sunny? Is it humid? It can fluctuate wildly within a single day.
Right. You can wake up to rain and go to sleep under a clear sky. That's weather.
That is weather. Climate, on the other hand, is the long game. It's the sum total of all those weather conditions and their variations, but over a huge area and for a very long period of time. The NCERT specifies more than 30 years.
30 years, okay.
So when we say India has a monsoon-type climate, we aren't talking about what happened last Tuesday. We are talking about a pattern that has been established over decades, even centuries.
But the ingredients, the elements we measure, they're the same for both, right? We aren't measuring different things.
Correct. The building blocks are identical. Temperature, atmospheric pressure, wind, humidity, and precipitation. It's only the timescale that changes. Now, to understand why India's climate is the way it is, we have to look at what the book calls the 6 major climatic controls.
The control panel for the atmosphere.
You could say that. They are latitude, altitude, the pressure and wind system, distance from the sea, which we call continentality.
Okay.
Ocean currents, and finally, relief features.
Let's unpack these, and let's really focus on how each one applies to India. Starting with latitude. This seems pretty straightforward. It's just where you are on the globe.
It is, but it has a very specific and profound implication for India. The Tropic of Cancer passes right through the middle of the country. It runs from the Rann of Kutch in the west all the way over to Mizoram in the east.
So it basically cuts the country in half, latitudinally speaking.
It does. And this means the southern half of India lies squarely in the tropical zone. The northern half, however, is in the subtropical zone.
And that explains why India's climate has characteristics of both.
Exactly. You get that intense year-round tropical heat in the south, but you also get the much more distinct seasonal changes of the subtropics up in the north. The very different experiences of, say, Chennai and Delhi.
Which brings us nicely to the second control, altitude. And for India, that means one thing above all else, the Himalayas.
The Great Wall of India, climatically speaking, I mean, the average height is around 6,000 meters. Now, the basic rule is as you go up, the temperature goes down. That's the lapse rate.
Right.
But the Himalayas do something far more important for the Indian subcontinent. They act as a barrier, a massive, massive barrier.
A barrier against what exactly?
Against the freezing cold winds that sweep down from Central Asia in the winter. If you look at other places at the same latitude as North India, parts of China, or even the U.S., they have much, much harsher winters.
But we don't.
We don't, because the Himalayas literally block that mass of cold air from pouring into India. That is the primary reason why our winters are relatively mild compared to other places at the same latitude.
So we've got the mountains protecting us from the cold. Now, let's talk about wind and pressure systems. Specifically, let's talk about the Coriolis force. I feel like this is a concept that always trips people up.
It's pure physics in action, and it's so important. The Coriolis force is an apparent force that's caused by the Earth's rotation.
Okay.
Because the Earth is spinning, things like wind and ocean currents don't move in a perfectly straight line. They get deflected. In the northern hemisphere, they get deflected to the right.
And to the left in the southern hemisphere.
Exactly.
And this isn't just some abstract textbook definition, is it? This came up very recently in the exams.
It did. You just have to look at the 2024 prelims. There was a question specifically testing the properties of the Coriolis force. It asked about its relationship with wind velocity and with latitude.
And what was the key takeaway from that question? What did aspirants need to know?
The statement to evaluate was whether the force increases with wind velocity and if it's maximum at the poles and absent at the equator. And that is absolutely 100% correct.
So 0 at the equator.
0 at the equator.
Yeah.
This is crucial. It's why you almost never see cyclones or hurricanes forming exactly at the equator. There's no spin to get them going.
I see.
But as you move towards the poles, that deflection force gets stronger and stronger, reaching its maximum at the poles. And this whole force is the reason the trade winds don't just blow straight north-south, they bend. And that bend is absolutely critical for how the monsoon works.
Okay, so we've set the stage with the controls. Now let's look at the machine itself. Section 2, the mechanism of the monsoon. The word itself has a pretty cool history, doesn't it?
It does, yeah. It comes from the Arabic word mausam, which literally just means season. The Arab traders who sailed the Indian Ocean were the first to really document this phenomenon. They noticed this complete seasonal reversal of the wind system. For 6 months, the wind blows consistently from one direction, and then it flips.
And that flip is the engine of our entire economy. But why does it flip? What's the actual physics behind the monsoon?
It's a massive game of pressure differences. And those pressure differences are caused by what we call differential heating.
Okay, break that down.
Step 1, land heats up and cools down much faster than water. This is basic physics.
Right. Go to the beach on a hot day. The sand is scorching, but the water is still cool.
Exactly that. So in the peak of summer, the huge Indian landmass and the Tibetan Plateau get scorching hot. This intense heating creates a massive, intense, low-pressure area over the interior of the subcontinent.
Meanwhile, the ocean is lagging behind.
The Indian Ocean to the south is much cooler, relatively speaking. That creates a stable high-pressure zone over the water.
And wind always moves from an area of high pressure to an area of low pressure.
Always. So the wind just rushes from the high pressure over the ocean towards the low pressure over the land. And because that wind is coming from the ocean, it's laden with moisture. Boom, that's your monsoon rain. That's the simplified version.
But the NCERT gets more specific. It talks about the ITCZ.
Yes, the Intertropical Convergence Zone.
Yeah.
This is it's a low-pressure trough where the trade winds from the northern and southern hemispheres converge. Normally, it hangs out near the equator.
But not in the summer.
Not in the Indian summer.
Right.
The sun is directly overhead the Tropic of Cancer, so this entire thermal belt, the ITCZ, it shifts north. It parks itself right over the Ganga Plain. We call this the monsoon trough. Oh, yeah. And this trough acts like a massive atmospheric vacuum cleaner, pulling those winds in.
The book also mentions Madagascar. Why do we care about an island so far off the coast of Africa?
Because of the push factor. There is a permanent, very strong high-pressure area that sits to the east of Madagascar at about 20 degrees south latitude. The intensity and position of this high-pressure cell are incredibly important.
How so?
It's what gives the monsoon winds their initial push. It forces that moist air from the southern hemisphere to cross the equator and head towards the low pressure in India. If that high pressure near Madagascar is weak in a particular year, the monsoon push is weak. The onset can be delayed or the rainfall can be less.
So it's a massive push and pull system. Wow. Now, this all connects to these big global weather phenomena, teleconnections they're called. The insert mentions the Southern Oscillation.
This is where it gets really interesting and highly relevant for the exams. The Southern Oscillation, or SO, is basically a pressure seesaw.
A seesaw.
Yeah. Normally, when the tropical eastern South Pacific Ocean off the coast of Peru has high pressure, the tropical eastern Indian Ocean has low pressure. But every few years, this entire pressure system just reverses. It flips.
And this flip is what leads us to the dreaded El Niño.
El Niño, yes. The insert defines it simply as a warm ocean current that flows past the Peruvian coast, replacing the usual cold Peruvian current. But for UPSC, you need to understand the consequence of that warm water.
And this has definitely come up, the 2014 Mains GS1 paper. The question was, and I'm quoting here, most of the unusual climatic happenings are explained as an outcome of El Niño effect. Do you agree?
That is a classic critical thinking question. The textbook tells you that El Niño involves the warming of the sea surface off Peru. This weakens the trade winds and essentially messes up that pressure seesaw we just talked about.
And for India, what's the bottom line?
For India, an El Niño year usually means a weaker monsoon, or in some cases, severe droughts. But the question asks if most unusual happenings are because of El Niño, and that's where you have to be nuanced.
So it's not a simple yes or no.
Not at all. You have to agree that it's a major, major global disruptor, but then you have to argue that it's not the only factor. There are other players on the field.
Right, which brings us to the Indian Ocean Dipole, or the IOD.
Exactly, and this came up in the 2017 prelims. The question directly compared the IOD to El Niño. The IOD is a similar phenomenon, but it happens within the Indian Ocean itself.
Okay.
It's the difference in sea surface temperature between the western part of the Indian Ocean near the Arabian Sea and the eastern part near Indonesia. A positive IOD means the western Indian Ocean is warmer than the east.
And what does a positive IOD mean for our monsoon?
It's actually good for the Indian monsoon. That warmer water in the west enhances the low pressure and can lead to more rainfall. In some years, a strong positive IOD can actually counteract the negative effects of an El Niño.
So El Niño is usually the villain, but a positive IOD can sometimes be the hero that swoops in to save the day.
In a very simplified way, yes. And the exam demands that you understand this complexity. These aren't isolated events. They are all interconnected gears in this massive global climate engine.
Okay, that's a great overview of the mechanism. Let's move to Section 3, the seasons. The insert divides the year into 4. Cold weather, hot weather, advancing monsoon, and retreating monsoon. Let's start with winter, the cold weather season.
Right. This runs from about mid-November to February. The sun has moved south into the southern hemisphere. The northern part of India gets quite cold.
And the winds change.
The winds completely reverse. The prevailing winds are now the northeast trade winds. Crucially, they blow from land to sea, from the high pressure over the Himalayas towards the lower pressure over the ocean. Since they're coming from land, they are dry. That's why winter is generally a dry season in most of India.
But there's a huge notable exception, which I always find so fascinating. Tamil Nadu.
Yes, the Coromandel Coast. It's a classic exam topic. If you just look at a map, you can see why. Because of the shape of the Bay of Bengal, these northeast winds actually travel over the sea for a bit before they hit the Tamil Nadu coast.
Ah, so they pick up moisture.
They pick up a lot of moisture from the Bay of Bengal and then dump it on the coast. So while Delhi is dry and cold, Chennai is getting its main rainfall of the year.
And while that's happening in the south, up in the north, we have the western cyclonic disturbances.
A vital, vital winter phenomenon. These are essentially weather systems, temperate cyclones, that originate way over in the Mediterranean Sea.
Mediterranean, that's so far away.
It is. They are carried eastwards by the westerly flow, the high-altitude jet streams, across Iraq, Iran, Afghanistan, Pakistan, and finally into northwest India.
And why are they so important for us?
Agriculture. 100% agriculture. They bring that much-needed winter rain to the plains of Punjab, Haryana, and western UP, and they bring heavy snow to the Himalayas.
Which is good for the rivers later.
Good for the rivers, and that winter rain is absolutely critical for the rabi crops, specifically for wheat. Without these western disturbances, our wheat production would suffer massively.
This links so well to general questions about cropping patterns and water availability outside the monsoon months.
Okay, let's flip the switch. From cold to hot, the hot weather season, March to May.
The heat belt effectively shifts north with the apparent movement of the sun. It gets hot, really, really hot.
And the pressure drops.
The pressure plummets. And we see some very unique, localized phenomena here. First, of course, is the loo.
The loo is brutal. I think anyone who has lived in North India knows it. It is. Strong, gusty, hot, dry winds that blow during the day over the north and northwest. Direct exposure can be fatal. But you also get dust storms, which, ironically, can sometimes bring temporary relief because they might be followed by a little light rain or a cool breeze.
And there are local storms with very specific names, right? Kaal, Baisakhi in West Bengal.
Yes, the calamity of the month of Baisakhi. These are violent thunderstorms, often with hail. And down south, particularly in Kerala and Karnataka, you get what are called mango showers.
Mango showers? That sounds much nicer.
It is. They are pre-monsoon showers that, as the name suggests, help in the early ripening of mangoes.
Now, talking about all this heat, we have to bring in an applied geography concept. The 2013 Mains GS1 paper asked this question. Bring out the causes for the formation of heat islands in the urban habitat.
This is a perfect example of how UPSC takes a static concept like summer from the NCERT and applies it to a modern dynamic reality.
How does it connect?
Well, the NCERT describes the general climatic heat of the season. But in our cities, that heat gets trapped and amplified. Concrete, asphalt, all the building materials. They absorb heat during the day and release it very slowly at night.
So the city doesn't cool down.
It doesn't. Plus, you have a lack of vegetation, which means less cooling from transpiration. You have tall buildings that block wind flow. So, cities become these islands of heat that are significantly warmer than the surrounding rural areas that are described more generally in the textbook.
So when you're reading hot weather season in the NCERT, you should immediately be thinking about how urbanization and our city planning are making that heat even worse.
That is exactly the kind of linkage the exam expects you to make.
Okay, let's move on to the main event. Section 4, the advancing monsoon, the rainy season.
This is it. This is when those moisture-laden winds from the southern Indian Ocean finally cross the equator, get deflected to the right by the Coriolis force, and hit the Indian Peninsula as the southwest monsoon.
And it doesn't just, trickle in. The book uses a very specific word. It bursts.
The burst of the monsoon. It's not a gradual increase. It's a sudden, violent, and continuous increase in rainfall. It usually hits the southern tip of the peninsula, the Malabar coast, around the first week of June.
And then it splits.
It splits into two main branches, the Arabian Sea branch and the Bay of Bengal branch.
Let's track them. The Arabian Sea branch moves north up the west coast.
Right. It hits Mumbai roughly around the 10th of June. It's a very rapid advance up the coast. Meanwhile, the Bay of Bengal branch moves even faster. It shoots north up the bay and arrives in Assam in the first week of June.
Then it hits a wall.
It hits the mountains in the northeast, the Burvankal Hills. It gets blocked and is forced to deflect to the west, where it then moves up the Ganga Plains towards Punjab and Haryana.
So Delhi is actually waiting for the Bay of Bengal branch to arrive, while Mumbai is already getting soaked by the Arabian Sea branch. Eventually, the two branches meet.
They do. They finally merge over the northwestern part of the Ganga Plains, somewhere around Himachal Pradesh.
Now, the rainfall isn't uniform at all. We have the rain-shadow effect.
This is absolutely crucial for understanding India's agricultural and ecological diversity. The Western Ghats are a tall, continuous range of mountains. The moisture-laden Arabian Sea winds hit them and are forced to rise.
And as air rises, it cools and condenses.
And dumps massive amounts of rain on the windward side. Places like Mumbai, the entire Konkan coast, get torrential rain. But once that wind crosses the peak of the Ghats and starts to descend on the other side, it warms up, and its ability to hold moisture increases.
So it stops raining.
It stops raining. That's the leeward side, or the rain shadow area. This is why the Deccan Plateau, large parts of Maharashtra and Madhya Pradesh, get significantly less rain, despite being geographically so close to the coast.
It's a completely different world, just a few hundred kilometers inland.
Completely.
Another critical concept from the book is the break in the monsoon. It doesn't just rain continuously every single day for 4 months.
No, not at all. There are wet spells and there are dry spells. The insert explains that this is related to the movement of the monsoon trough, that low-pressure belt we mentioned earlier. This trough doesn't stay in one place. It moves north and south.
So what happens when it moves?
When the trough's axis lies over the plains, you get good, widespread rainfall there. This is great for agriculture.
Oh.
But when the axis of the trough shifts closer to the Himalayas, the plains go dry. That's the break.
But rain must be falling somewhere.
Oh, yes. This shift causes heavy, widespread rain in the mountainous catchment areas of the Himalayan rivers.
Which leads to this terrible, tragic irony.
It does. You can have a break in the monsoon, leading to drought-like conditions in the plains, while at the very same time, you are facing devastating floods because the rivers coming from the mountains are overflowing with all that rain from the catchment areas.
This variability creates so much uncertainty. It must be a nightmare for farmers.
It's the central challenge of Indian agriculture. And this links directly to a 2022 prelims question about the Climate Action Tracker. We need these modern tools to monitor and predict these uncertainties because our food security, our entire economy, depends on it.
Okay, so the rains have advanced. Let's transition now to Section 5, the retreating monsoon. The rains are leaving.
Right, this is October and November. The sun is now moving south again. The low-pressure trough over the northern plains weakens and is gradually replaced by a high-pressure system. The southwest monsoon winds weaken and start to withdraw.
But it doesn't immediately become cool and pleasant. The book talks about the October heat.
Ugh, yes. It's the worst of both worlds, really. The land is still saturated and moist from the monsoon rains, but the sky clears up and the sun beats down, so you get high temperatures combined with very high humidity. It's incredibly oppressive weather.
And as this withdrawal happens, the center of atmospheric action shifts from the land to the sea, specifically to the Bay of Bengal.
This is where we see the formation of cyclones. This is a major, major focus area for UPSC. The low-pressure conditions that were over North India transfer over to the Bay of Bengal. This shift is the trigger for the formation of cyclonic depressions.
And the exams are all over this topic. The 2013 mains asked about cyclone Phelan and the general system for how tropical cyclones are named.
Right, and the 2014 mains asked a much deeper, more conceptual question. Tropical cyclones are largely confined to the South China Sea, Bay of Bengal, and Gulf of Mexico. Why?
So why is that? Why the Bay of Bengal so much more than, say, the Arabian Sea, at least historically?
It comes right back to the climatic controls in the NCERT. To form a cyclone, you need several conditions. First, you need a large, warm sea surface with temperatures above 27 degrees Celsius to provide the energy.
Fuel for the storm.
Exactly. Second, you need the presence of the Coriolis force to create the spin. The Bay of Bengal is partially enclosed, so its waters stay warmer for longer than the more open Arabian Sea. Plus, you get a lot of remnant typhoons from the South China Sea that cross over Southeast Asia and re-emerge and intensify in the Bay of Bengal.
That's fascinating. And connecting this even further, in the 2019 mains, there was a question about the formation of islands in Indonesia and the Philippines.
Right. And you might think, what does that have to do with climate? But those archipelagos are in that same tropical belt. The tectonic activity creates the islands, but the climatic conditions we're discussing, the warm oceans, the strong Coriolis force, are what make that entire region the world's most active breeding ground for these massive storms.
It's all one interconnected system.
It truly is.
Now, Section 6, this is the big one for modern context. Climate change, water, and the environment. The NCERT mentions that heavy rains cause devastating floods, but UPSC takes that a step further and asks about urban floods.
Yes. The 2020 mains GS1 question was very specific. Account for the huge flooding of million cities in India, including the smart ones like Hyderabad and Pune.
So how do we link the Class 9 textbook to this very modern problem?
The textbook talks about the bursts of the monsoon and the intensity of depressions. Climate change is making these bursts more intense. We're getting more rain in fewer days. The fundamental phenomenon is the same, but it's on steroids.
And our cities can't handle it.
Our cities can't handle it. That's the urban aspect. We've paved over everything. We've destroyed natural drainage systems like lakes and wetlands. So when that super intense NCERT-described rain hits, the water has absolutely nowhere to go.
Which brings us to the solution side of things. The 2014 mains asked about the benefits of the Integrated Watershed Development Program,
which is essentially about managing water where it falls. It's about preventing soil runoff, promoting rainwater harvesting, and increasing green cover. The NCERT explicitly mentions how vegetation density is linked to rainfall and runoff. If you strip the vegetation, you get floods. Watershed development is the policy action that tries to reverse that process.
And speaking of water, we have to talk about the source of our northern rivers, glaciers.
Another 2020 mains question. How will the melting of Himalayan glaciers have a far-reaching impact on the water resources of India?
Right.
The insert mentions snow in the Himalayas as a key climatic control. But what happens when that control is disrupted by global warming? If that snow and ice melts too fast, you get devastating flash floods in the short term, but you face long-term water scarcity. The great rivers that feed the northern plains, the granary of India, could lose their perennial flow and become seasonal.
The consequences are almost unimaginable.
They are.
And looking at the 2014 prelims, there was a question about the scientific view on a 2 degrees Celsius global temperature increase.
It asked about the likely impacts, like widespread coral mortality and the disappearance of wetlands. This just reinforces that climate isn't just about will it rain tomorrow. It's about the fundamental survival of entire ecosystems.
And just this year, in the 2024 prelims, there was a question on tropical peatlands. How does it connect?
It's a fantastic connection. Peatlands are massive, massive carbon sinks. They store more carbon than all the world's forests combined. The high rainfall areas that this chapter describes, like parts of Northeast India or Southeast Asia, are what support these peatlands. If the climate changes and these areas dry out, the peatlands start to decompose and release all that stored carbon back into the atmosphere. It's a terrifying feedback loop.
Wow. Okay, let's bring this home. Section 7. Monsoon as a unifying bond. This is a beautiful, almost poetic concept to end on.
It really is. The insert concludes with this idea that despite all the incredible diversity in India's climate, we have the wettest place on Earth, moss and rem and bone-dried deserts in Rajasthan. We have freezing temperatures in Dras and a stable tropical climate in Kerala. The monsoon binds the entire country together.
How does it do that?
It provides a common rhythmic cycle of seasons. The entire agricultural calendar of the country is synced to the arrival and departure of the monsoon. Festivals are synced to it. The river systems that connect the geography of the country are all fed by it.
It's the one rhythm that the whole country moves to.
Exactly. But, and this is a big but, if we refer back to that 2016 mains question about unusual climatic happenings and El Niño, this bond is under stress.
Go on.
When the monsoon fails or becomes erratic, that unity starts to strain. Water disputes between states flare up. Food prices skyrocket, causing economic and social unrest.
That is a very profound point. The monsoon unifies us, but its instability has the power to divide us.
Precisely. It's a fragile bond.
Okay, let's wrap this up with a quick recap. We've covered a fundamental distinction between climate and weather. We've mapped out the 6 major climatic controls: latitude, altitude, pressure and wind, continentality, ocean currents, and relief.
We've broken down the engine of the monsoon, the differential heating, the shifting of the ITCZ, and the role of global teleconnections like El Niño and the IOD. We've walked through the 4 seasons, from the freezing westerlies of winter to the scorching loo of summer, and we traced the 2 branches of the advancing monsoon across the subcontinent.
We've also looked at the why behind the cyclones in the Bay of Bengal and, crucially, connected all these textbook docs to the pressing realities of climate change, urban flooding, and glacial melt, just like the UPSC expects you to.
And we've seen that the monsoon is so much more than weather. It is a unifying, albeit increasingly volatile, bond for the entire subcontinent.
So here's a provocative thought to leave you with. The insert calls the monsoon a unifying bond. But as climate change makes the monsoon more erratic, more intense bursts, longer breaks, more destructive cyclones, does this threaten the political and social unity of the region? If the bond itself becomes unreliable, what happens to the entity that it binds?
That's something to think about for your mains conclusions, for sure.
Absolutely. Thank you so much for diving deep with us today. And once again, this was a special breakdown for the Simplified UPSC by PPP community. Please, if you haven't already, take a moment to subscribe to the channel. It really makes a huge difference.
And if you can, please consider supporting us on Patreon so we can keep the lights on and this high-quality content flowing.
Head over to the public Telegram channel for all the free notes and the PYQ documents we discussed. And for the really serious aspirants, DM us there to join the premium library for that organized, all-in-one experience with model answers.
Study hard and stay curious.
We'll see you in the next deep dive.